When we talk about quantitative reasoning, we are looking at how to think or reason with numbers. Another name we use for quantitative reasoning is quantitative literacy or numeracy. Now, there are two parts to being numerate, and the first part has to do with being able to understand math in context. And so we look at some examples like understanding the order of operations, how to solve proportions, or using formulas and knowing if the answers that you derived from these are reasonable. The second part has to do with being able to read a news article with percent statements and understand graphs, tables, charts, knowing what formulas are used in, let's say, a science journal or a science problem. So these are the two main parts that we'll be looking at when it comes to being numerate. The only way we can improve our quantitative reasoning is if we actually practice reasoning. We'll try to work in groups in discussing how best we can interpret the meaning of a sentence or a calculation that we've done. We'll monitor our progress. We'll look at how to communicate effectively when we are together trying to solve a problem and interpret the meaning as well. How do we measure our reasoning? When doing math calculations, you'll be graded on how you apply some correct techniques. And many times you'll be asked to communicate the meaning or interpret the meaning of the numbers that you found. So we talk about writing meaningful sentences. So that's not just about the values that you calculate, but how do you interpret the meaning of the result that you have. The example says compare the Gary campus, which is 2,441, with the Fort Wayne campus, which is 6,705. And in this case, we're looking at enrollment in both campuses. The first says Fort Wayne has a lot more students than Gary. What we see here is using a vague statement by saying a lot more. A lot more doesn't specify quantitatively how much difference we are looking at in terms of both campuses. The second part says there's a difference of 4,264. It also doesn't tell how it's taking the difference or what we're talking about here. Are we talking about the difference between enrollment in both campuses or not? But the third says there are 4,264 more students enrolled at Fort Wayne than there are at Gary, which means that we know exactly where this difference is coming from. The students that are enrolled in Fort Wayne are more than students that are enrolled in the Gary campus when we take the difference between these two numbers. So when we take the enrollment in Fort Wayne minus that of the Gary campus, then we have a difference of 4,264 students that are enrolled more in Fort Wayne than they are in Gary. So this becomes the best reasoning for this example. The next thing we're going to look at is the equivalent forms of numbers. When we talk about the equivalent forms of numbers, we're looking at the different ways in which we can write a certain number. And so when we take a look at the example here, we are looking at numbers that can be written as fractions, as decimals, as reduced fractions, per 10, as values per thousand, and so on. What we see common with these numbers is that they are all related because they are the same numbers. And so we say that these values are all equivalent. Now, I mentioned that we can write some of the numbers as reduced fractions. And so in this example, we look at how to write the lowest terms of fractions. When we talk about the lowest terms of fractions, we are looking at writing the fractions in a way that we can no longer divide. When dealing with fractions, you want to make sure the numbers that you're dividing or multiplying by are the same. So you divide the numerator and denominator or the top and the bottom numbers by common factors, making sure that whatever you're doing to the top, you do the same to the bottom. So if we have this example here, 28 over 42, what we want to do is to reduce this fraction to its lowest terms. And one of the things or one of the ways in which we can do that is to divide this by 2. And so we do the same top and bottom. That gives us 14 over 21. This is not the lowest term because we can still divide both. And so if we divide this by 7 and divide this by 7, that gives us 2/3. And this becomes our lowest fraction because after this, we can no longer divide or multiply anything on top and at the bottom. So this becomes the lowest fraction. We can also do the same here. If we multiply 45 by 1/15 and then 60 by 1/15, that gives us a reduced fraction of 3/4, which becomes our lowest fraction. And so again, remember that whatever you do on top, do the same at the bottom. And that's how we're able to reduce these fractions to its lowest terms. You have a few more examples on the homework problems to help you practice more. Other times, when we have large numbers like these, it will take a lot of time trying to reduce this to its lowest term. And so we use decimal equivalent. What that means is you can just use your calculators to compute the solution for these large numbers. In determining the equivalent numbers, we can just use our calculators to do that. For example, when we want the equivalent form of 28/42, as we did before, using our calculators, we can determine this value to be 0.6666. Tells us that we should round to the third place. If we are rounding this to the third place, that gives us a value of 0.667 because the next number is greater than 5, and so we take that as a 1 and then add it to this number. 7/13, when we do this in our calculators, we have this value. That rounded to 3 places becomes 0.538 because the number after is less than 5, and so that is considered a 0. When you add a 0 to it, we still have our 8. And so these are ways in which we can write numbers in its decimal equivalent forms. There are naming conventions when it comes to decimal parts of numbers. And so these are the ones, the tenths, hundredths, and so on. Another way of thinking of these decimal values is per 1. So that whenever we write a decimal, it's a value per 1, which means that applying the same principle, we can write these numbers as values per 10, per 100, or per 1,000. So if we multiply the numerator by 10 and the denominator by 10, that gives us our value per 10. If we multiply by 100, it gives us our value per 100. If we multiply by 1,000, it gives us our value per 1,000. So in this example here, we'll look at how to write these numbers as percentage. And percentage is a name that we use to represent values per 100. And so we're going to write these decimals as percentages so that if we have a decimal 0.86, writing it as a percentage means that you're multiplying it by 100. So if we multiply 0.86 by 100, that gives us 86%. Another way we can look at this is by moving the decimal point 2 places to the right. If we move 0.86 2 places to the right, then it gives us 86, and then we add our percent to it. If you have 2/2500, this is the same as 1.25. Since these are decimals per 1, if we want the percentage, we multiply this by 100 and then multiply this by 100, which gives us 125%. Or again, we can move the decimal 2 places to the right, and that still gives us 125%. Similarly, we can write these numbers as fractions per 100, per 1,000, per 10, meaning that we want our denominator to be 10, then 20/100. If we divide this by 10, divide this by 10, that gives us 2/10. If we already have this decimal 0.79, which is per 1, and we want it to be per 10, then we can just multiply this by 10, multiply this by 10. Again, the goal is to have a denominator that is 10. And so this becomes 7.9, or this means just move the decimal 1 place to the right, and that gives us the fraction per 10. If we want fractions per 1,000, we do the same, multiply both sides by 1,000. 6/25 expressed as a decimal is 0.24. We know this is a decimal per 1, so to have a value per 1,000, we just have to multiply this by 1,000, multiply this by 1,000, or move the decimal 3 places to the right, which gives us 240/1,000. If we have a decimal, which is per 1, we can do the same, multiply by 1,000, multiply this by 1,000, and that gives us 321 over 1,000. Or again, you can move the decimal 3 places and then divide by 1,000, which will give you the same value. Finally, we're going to review some rules for rounding. The few rules that you need to know about rounding is, first, you need to locate the digit that the number is to be rounded to. In this case, if we are rounding 875 to the nearest 100, this is our ones, this is our tens, this is our 100. So our 100 place will be this number right here. If we are rounding this to the nearest 10, this is our 1, this is our 10, so our 10 place will be this number here. If the digit you're rounding to is followed by a number less than 5, then you leave the digit to be rounded the same and make the digits to the right of the rounded digit 0. This is called rounding down. So if you're rounding this to the 100 place, then this becomes 9. And so this becomes 900 when rounded to the nearest 100 place. And then this becomes 1770 when rounded to the nearest 10. When working with money, we generally round numbers to the nearest cent or the 100th place, so that money is rounded to 2 places. And so this becomes $3,674.86. And if we want to round this number to the nearest dollar, then it becomes 7,500 or $7,500. This is the end of pre-lecture 1 on section number 1.